Hello everyone, my name is Sahajpal Singh and my topic is titled as Exoplanets and Their Detection. Well, one of the most spectacular things about exoplanets is that the public is very interested. In public imagination, we are on quest of the pale blue dot. Sir Carl Sagan used this image to put our world into entirely new perspective. And since then, we all have been inspired to see images like this. But here we are not in quest for the pale blue dot, but pitch black dot. The reason I love pitch black dot is that it's shadow of a planet eclipsing its star. It's interesting to note that we can detect it even if we cannot spatially resolve planet from the star. So by carefully observing the planets on the face of star and seeing the changes in stellar flux, we can detect whole new distant worlds and study their properties. So, what is an exoplanet? Well, exoplanet is any planet outside our solar system. The majority of exoplanets orbit their stars, while rogue planets or free floating planets orbit the galactic center and are unattached to any star. Extrasolar planets range in size from gas giants larger than Jupiter to small rocky planets roughly the size of Earth or Mars. Coming to exoplanet detection techniques, there are five major techniques developed to detect them, and the new ways of hunting the worlds beyond are a topic of research, and we are finding new planets with some new techniques as well. The five techniques used are radial velocity, transit method, direct imaging, gravitational microlensing, and astrometry. Out of all these five, most planets have been discovered with the help of transit method because of its ease of access. Here is an example of a planet transit method. Planet is orbiting in its plane, and when it comes and casts shadow on the sun, we see a dip in the light curve. So this dip in the stellar light can let us know about the possible existence of some planet, and it can be also used to study its properties. So the planetary transits, as I said, are the key to discover more properties about exoplanets, such as their actual mass and radius of planet, the planet bulk properties, their atmospheric properties of the planet, the stellar properties, and much more. So here is a recent data provided by James Webb Telescope, in which we have seen that it has discovered signatures of water molecules in its atmosphere. So basically, when the planet transits its star, we can measure the size of planet and see the star's radiation transmitted through the planet's atmosphere. So studying atmosphere of an exoplanet can answer if the planet is inhabited or not. Like life, if exists, can introduce some organic molecules into the atmosphere of the planet that otherwise would not have been there. So, for an instance, like Earth's atmosphere has a lot of oxygen because plants are producing it. Otherwise, being very reactive gas, oxygen would have combined with other minerals and form oxides. So, planetary transits can be used to discover a habitable planet like Earth. So planetary transits and Doppler shift. With the Doppler shift, we can detect like how the planet is transiting. Like, like we can see that in case of light waves, shorter waves, which are compressed waves, correspond to blue color, and longer waves correspond to red light. So stars orbiting their center of mass, if moving away from the observer, would appear slightly red. So like this side of sun is moving towards the earth. So it would appear slightly red, and this opposite side moving away from the earth will appear to be blue. So this is the Doppler method for detecting planet that exerts a pull on its parent star. So when the planet is starts transiting this star, so it will block most of the blue light from the star, and it will show the red shift. We'll see the red shift. And when it passes along its red portion, then we will only observe blue shift throughout the entire eclipse, like this. So by these Doppler shifts, we can know about the angle between the orbit of the planet and star's equatorial plane. So if we have a shift like this, so it will be a well-aligned planet in its orbit, and the transit will be like radial, like this in this case. So if we have this kind of Doppler shift, then it will be some misaligned. So this gives a sneaky way to figure out how planet's orbit is aligned. The planet is tilted at some crazy angle like this and spend entire eclipse hiding the red side of the star, then we would only observe the corresponding blue shift, like in this case. So thank you.